Hi, Math to Enhance. Before we start in on our packet on arc length and sector area, I want to show you where my equations come from. So first of all, the length of an arc, if I have a circle and I've got some angle inside my circle, I don't know what that is, but it looks less than 90. So maybe that's 80 degrees, or maybe that's 75 degrees. Theta is some degrees. So this is in degrees right now. Then this is my radius. Then this is what we call an arc length. It's the length of an arc. And we abbreviate that with an S. And if we're in degrees, this little red arc that you see there is some portion of the circle. It's theta divided by 360 degrees in the circle. That's going to tell me, is it 1/4 of the circle? Is it 1/5 of the circle? Is it 2/3 of the circle? Is it 7/8 of the circle? That's giving me the fractional part that highlighted red arc is. And then I take it times the circumference. You might remember that as 2 pi r from back in the day. That is the distance all the way around your circle. And so if I clean this up, I can cancel from the 360 the 2, and we say that arc length is theta times pi over 180 times that r. So theta times pi, and the 2 and the 360 canceled to 180 in the denominator times my radius. This is if it's in degrees, and we're going to write that down in just a minute in our packet. What about the sector area? So let's take that same red circle. Let's take that same area, that's theta. The sector area is all of this. It's like a piece of pizza, if you will. I want to find the area of this little sector, and I've got my theta and I've got my radius. And so we say sector area, when I'm in degrees, is equal to the part of the circle that's shaded. So this is what fraction of the circle, 80 out of 360, 40 out of 360. It's like my 1/4, it's my 1/5, it's my 1/2 the circle. It's like the fraction of the circle that's highlighted in red times the area of the entire circle will give me the part of my circle that's shaded. So we write this as area equals theta times pi divided by 360 times r squared, because that's the area of my circle. And this is when I'm in degrees. What about when I'm in radians? So let's take another circle. Let's take another theta, some, 85 degrees, 88 degrees, 80 degrees, something like that. And I have my radius. Now, to get the part of my circle, it is, for my arc length, it's some fraction of the whole circle. So theta divided by, and now if I'm in radians, my whole circle is not I lost my pencil. My whole circle is not 360 degrees anymore. It's 2 pi radians times the arc length of the entire circle, which is 2 pi times r. That's the distance all the way around your circle. So you'll notice that the 2 pi and the 2 pi cancels. So when I'm in radians, my arc length is just theta times r. Much, much simpler in that sense, theta times r. What about my sector area? So let's fill in that little portion of my circle, my theta, shade that in. And if I want to find that area, then I would take the portion of the circle that's shaded, which is theta divided by 2 pi. That's the part of the circle that's shaded right there. Whatever theta is, it's that fraction of the circle, times then the area of the circle, which is pi r squared. So in this case, my pi's cancel, and that's why area, when you are in radians, is equal to theta divided by 2 times r squared. So let me go back up to this one and put the parentheses. So, and then I'll put the parentheses over here. Well, I don't think we need them. But anyways, these are the 4 equations that you and I are going to have to memorize. And I wanted to take a minute and talk about why these are the 4 equations. So let's go to the next page in our packet, and let's get busy. So across the top, let's write our equations so we have them on this page. My area is theta over 2 times r squared when I'm in radians. And my area equals theta times pi over 360. I don't want to write on top of anything. Let me erase this and go write that somewhere else. So my area is theta times pi over 360 times the radius squared when I'm in degrees. And yes, we have to memorize those too. What about when I'm doing arc length? So that's not the area of the circle, that's like that highlighted arc around the outside. Well, the arc length, for some reason, they use S as the abbreviation of arc length. So I'm going with it here, you guys. But this is going to be theta times the radius when you are in radians. And when I'm in degrees, my arc length is going to be theta times pi over 180, all times my radius. And again, that's when I'm in degrees. And yes, I have to memorize these. So let's start by doing some arc length problems. It says to round your answers to the nearest tenth. So I'm going to do it all on the calculator. I don't really care about the nearest tenth, hundredth, tenth, thousandths, whatever. It's a decimal. So this is my theta. 315 degrees is the part of the circle that is highlighted around the outside. I'd like to find the length of this red arc. Now it is 315 degrees. I mean, a central angle is equal to its length of its arc, so it'd be 315 degrees, but I'm trying to find that in feet. So my calculation for degrees is my arc length is theta times pi divided by 180 times my radius. So in this problem, that is 315 times pi over 180 times my radius, which is 11. Now when I'm doing calculations, we multiply numerators and we divide by denominators. So you and I are going to do 315 times pi times 11 divided by 180. If you put that in your calculator correctly, you should get 60.5 feet. Not squared because this is just a length. It's just a one-dimensional. So what does it look like when I'm in radians? Well, this is 3 pi over 2 radians. So I'm trying to find the length of this arc, and my theta is 3 pi over 2. So my arc length S, when I'm in radians, is my theta, 3 pi over 2, times my radius, which is 16. So this 16 is like over 1. So 3 times pi times 16, divide by 2, and I'm going to get 75.4 feet. Now, what if I want to have an exact answer? So let's talk about exact answer with radians. Exact answers mean that I am not going to round at all. So do not round. It's going to be in terms of pi. So in this problem, my theta is 315 degrees. So you and I are using our degree formula for arc length. So my arc length is theta times pi over 180 times my radius. And if I rewrite this every time, that's going to help us get this memorized. And I get my theta, which is 315, times pi divided by 180 times 8, which is in the numerator. So 315 times 8 divided by 180, I would do all that part on my calculator, and I get 14 pi centimeters. And this is an exact answer because I have not multiplied by my pi. So let's take a look at number 11, which is in radians. So on this one, I have to use that my arc length is equal to my theta times my radius. So in this problem, pi over 2 times 14. 14 divided by 2 is 7. So I get 7 pi, what are my units? Centimeters. 7 pi centimeters for my arc length. So let's do some sector area problems. So these problems, the first ones are asking me to round my answers to the nearest tenth. So just a decimal. I don't care if it's the nearest tenth or 100, that doesn't matter, but let's get decimals. So my theta, the portion of my circle that I'd like to find the area of, is 60 degrees worth of my circle. So I'm using my degree formula. Gosh, I'm trying to remember that. That was my theta over 360 times pi r squared, because this is the area of my whole circle, and this is the part that is shaded. So remember, we write that as theta times pi over 360 times r squared. So let's put in our numbers. our area is 60 times pi, 60 degrees times pi divided by 360. It's 1/6 of the circle, times my radius squared. So I really got to do 10 squared first, which is 100. And then we're going to multiply by 60, multiply by pi, and divide by 360 because it's in our denominator. And we're going to get 52.4 inches squared. Let's take a look at doing one that is in radians. Oh goodness, my radian formula. Well, remember, let's try to work it out. It's the part of my circle, so it's the part of the whole. So it's theta, which is a portion of my circle out of 2 pi, my entire circle in radians, times the area of the whole thing, which is pi r squared. It's the fractional part times the whole thing. Oh, and my pi's cancel. Oh, okay. So this one's formula, if I didn't want to flip my page back over, is just theta over 2 times r squared, which in this case is 3 pi over 2. Divided by 2 times 4 squared. Let's talk about 3 pi over 2 divided by 2. There's no such thing as a triplex here, you guys. Anything in the denominator is just in the denominator. This is really 3 pi over 2, and this other 2 is in that same denominator. Dividing by 2 is the same as multiplying by 1/2. In other words, that 2 is in the same place as the first 2. That's really 3 pi over 4. So this is really 3 pi over 4 times 16. So I do 16 times 3 times pi times 4, and I get 37.7 centimeters squared for my area. Well, what happens if I want my area to be in exact terms? In other words, I do not want to round. So I need to find the area, no rounding. In other words, I'm going to leave it in terms of pi. So first of all, I'm in degrees. And if I remember, that was theta times pi over 360 times my r squared. That was my area. So for this problem, it's 240 times pi over 360 times my 16 squared. So I showed you earlier this year how your calculator will do fractions for you, but let's just Sorry, I hope I haven't been muted for very long. Somehow I muted it. Lucky you guys. But anyways, I mentioned that earlier I showed you how to use your calculator to do a fraction. I'm going to talk about doing this on your calculator in a second. But let's just do this by hand real quick. I cancel my factor of 10. 24 and 36 both reduce by 4 to 8. Or actually, no, they just reduced by 12. What am I doing? Reduced by 12 to 2 pi over 3 times 16 squared. So 16 squared is 256. So it's 2 pi over 3 times 256, which is 512 over 3. And you can put the pi either beside it or the pi up with the 512. It's in the numerator. It doesn't really matter if you write it 512 pi all over 3 or 512 over 3 times pi. It's the same number, and that is feet squared since I'm doing area. Now, on your calculator, you would do like 16 squared times 2, divide by 3, and then it's going to give you a decimal. And then hit your fraction to decimal key, and then use your mixed number key to make it a mixed number if you'd rather. But I would just leave it as 512 over 3 pi. So then number 19 is in radian form. So when I'm in radian form, remember my area is just theta divided by 2 times r squared. So this is my 3 pi over 2 divided by 2 times my 14 squared, which is 3 pi over 4 times 14 squared. Again, I would do 14 squared times 3. It's an even number, so I'm sorry, it's a not even number. It's a divisible number by 4. So you're going to find when you do all that, you get 147. And so it's 147 pi centimeters squared. And no fraction decimal key needed for that one. Let's flip to the next page, shall we? So sometimes this page is the ones that are technically harder. We're going to just look at 25 and 27 right now. So sometimes I'm missing my radius or my theta. So in this problem, you can see they say S equals 15.87 feet. that is this arc length right here. And it gives me the radius, and it wants me to find theta. So this is in degrees. Does it say? Oh, it doesn't say. Oh, but the number 26 is in degrees. I think this whole page is degrees. Sorry, I will remember to tell kids in the classroom. So let's write down our arc length formula. My arc length, my S, is equal to theta times pi over 180, all times my radius when I'm in degrees. And so my S is 15.87 equals theta, which I don't know, times pi all over 180 times 7. So you've got a couple ways to solve this, but I usually just do it on my calculator. First of all, I just undo each of these on my calculator. So let me get a blue color, tell you what I mean. So I want to solve for theta. So I'm dividing by 180. The opposite of that is to multiply by 180. So I'm going to multiply that over. And on my calculator, I'm going to do 180 times 15.7. And I just got rid of that one. And then it's theta times pi times 7. So I'm going to divide by a 7 on both sides. That's going to get rid of my 7. I'm also going to divide by pi on both sides. And that's going to get rid of my pi. That's how I would do it. And then I would go to my calculator and I would do 180 times 15.87, divide by 7, and careful, divide by pi. I literally on my calculator, divide by 7, divide by pi. They're both in my denominator. Okay, and then just so you know, if you did that, I believe you should be getting around 129.9 degrees for theta, or around 130. Kind of depends on how exact your answers are. So I have another way for you to do that. Let me erase some of this. If you don't like my doing it in parts way that I tend to do it, pi over 180 times your 7. Then I would go get a decimal for all of this. So like on my calculator, which I don't have handy, but I would do, here, let's see, actually, there it is, pi times 7 divide by 180, and I get this number 0.12217, let's say theta, 15.87. So now take your 15.87 and divide both sides by your 0.12217, and you're also going to get 129.9. So we get 129.9, whether you do it piece by piece or whether you get one decimal and then divide it over. Both ways are fine. Let's take a look at 27. This one's about sector area of a circle with radius 12, and the sector area is 54 pi. What's the measure of the central angle in degrees? So this needs your area formula in degrees. So let's write area equals theta over pi divided by 360, all times r squared. So in this case, theta times, I don't want to do it that way. I want to go down to the next line, my bad. So my area is 54 pi equals theta, which I'm trying to find, times pi divided by 360 times 12 squared, which is 144. So again, you can either do it piece by piece. First of all, I would cancel pi on both sides, since there happens to be a pi on both sides in this one. I would multiply the 360 over, and then I divide both sides by 144 if I was just doing it on my calculator. Or you can go do this and get one decimal times theta, and then divide both sides by that decimal. When we get done doing it, we should get around 135 degrees for theta. Let me know if you're having calculator issues, like if you're having trouble solving it because you can't get your calculator. But like I said, I have 54 equals theta times 144 over 360. So over here, I'd be multiplying the 360 over, I'd be dividing by 144, because multiplying by 360 cancels the 360, and dividing by 144 cancels the 144. And that would be in the numerator. So 360 times 54 divided by 144. Or you found the decimal and you divided both sides by the decimal, if you like that better. We should be getting 135 degrees. I hope this was helpful. And if you have questions, bring them to office hours.